Okay.
Alrighty, so let me go ahead and hit record here, and then we'll go ahead and get started. Let's see. Alrighty, welcome everyone again. Welcome to our second to the last event here with Finals Countdown. So we only have 2 more sessions left with Finals Countdown. We have this session with Ernest, and then we have my session at 3 o'clock. So Ernest today will be doing Math 102, focusing on geometry. And at 3 o'clock with me, we'll be going through the art of revision, which will be at 3 o'clock, hosted by me. So 2 more sessions left, 2 more evaluations to fill out. Just an update, we probably won't be doing the drawing until next week on Monday or Tuesday, but we want to have a chance for students to finish all of their evaluations and things like that. So we'll be following up through email to students that have been participating through Finals Countdown. So yeah, just an update there. And then, as you guys know, yesterday I wasn't actually here. So Audrey was facilitating the events and things like that. So awesome. So we'll go ahead and get started here with Ernest, who will go through Math 102 geometry. Go ahead, Ernest.
Okay, can everybody hear me well again? All right, good. So let me share my screen. Geometry. So we're going to be covering a few basic things. One of them is going to be geometric figures. Among them are segments. Segments are a line. We have this one from A to B. A ray, which is a line with an arrow at the end and can be shown here again with A to B, and it continues on. Lines again, so we have A, B, and C as being the line. Perimeter. To find the perimeter is you're going to find the distance around a shape, or you can say the sum of the lengths of the sides of a shape, and this will help you to find the perimeter. So I have here a chart, a graph with, well, a chart with the different names and the ways of finding the perimeter for them. As you can see in the top left corner, we have a square. To find the perimeter, you're going to find the side of 1 and multiply it by 4. So you add up all the 4 sides of the square to find the perimeter. Next is we have the circle. The circle is found by using 2 times pi times r. R is the radius as shown in the middle of the circle to going to the outer portion. A rhombus, again, the perimeter is going to be adding up all of the 4 sides or multiplying one side by 4. A rectangle will have 2 long sides and 2 short widths. So you would have 2 times A plus 2 times B. The perimeter for a parallelogram is 2 times A and then 2 times B added to 2A. So that's how you would find the perimeter of that. Then I have an ellipse, which is 2 pi to the square root of a squared plus b squared over 2. A triangle, you just add up all 3 sides of it, A, B, and C. A trapezoid, as it is here, A plus B plus C plus D, or 2m plus c plus d, and then a certain number of polygons here. So you would just have the number of the sides here added together, or the number of sides multiplied the number here. All right. So you're going to be, for my examples, I would like to have people to try to find the perimeter of this rectangle. And if you can, post your answer in the chat. That way I can see if you have followed. So the perimeter is adding up all of the sides. So we have a length of 6 inches and a width of 5 inches. So what would the perimeter be if you were to add up all of the sides? So we're getting people to respond. And of course, if we add up all the sides, we have 2 sides of 6 and 2 sides of 5. We add them up and we do get 22 inches. That is right. For those of you that answered in the chat box. Okay, we're going to find the perimeter of another object right here. So this time it has different lengths. So I'm going to give you some time to add up all of the sides and see what you get, and you can answer in the chat box. All right, so we add 3 and 7, we get 10, 5 and 5, 10. So our answer is 20. So good job of those of you in the chat box. So perimeter, you're just basically adding up all the sides of a shape, and you would use the according formulas. So next is area. So for area, you would have the shape and then you would use the formula. I have a few shapes here. We have a rectangle. To find the area, you multiply the length times the width. A square is the side times its other side. So it'd be the side square. So a square is equal all around. So you just multiply the side squared. A parallelogram is the base times the height. A triangle is 1/2 times the base times the height. A trapezoid is A plus B divided by 2 times the height. So the 2 sides added together divided by 1/2 times the height of the trapezoid. The circle is pi times the radius squared. Okay, so find the area of the rectangle that we have here. So we have 4 yards and 7 yards. So you can answer in the chat box again. I'll give you some time to work on that. So to find the area of a triangle, you would multiply the width times the length. So 7 times 4. And you would get 28 yards squared. So remember, when you do anything with a unit of measure to keep the unit of measure in place too. I know some people like to just give the number and they forget to give the unit of measure. So remember to keep it consistent. So you multiply the yards also. So now I'm gonna ask a different question. What is the formula to find the area of a triangle? I know people can do the math, but sometimes they forget how the formula is written. Then that's where they come into problems. So what is the formula to find the area of a triangle? You can enter in the chat box. So a visual representation of a triangle. Yes, that is correct. It'd be 1/2 times the base times the height. So that is the area. Thank you for those of you answering in the chat box. That's great. All right, so the surface area, we have some shapes here that we have a rectangular solid. The surface area is 2 times the length times the width times the height, width times height added together. A cube is 6 times the side squared. So a cube is made up of 6 sides with squares. So that's why you would have all the sides squared. A sphere is 4 pi. A cylinder is 2 times pi squared plus 2 pi, the radius times the height. And a circular cone with pi r squared plus pi r times t. Okay, now we get into some angles. I know that we deal with a lot of shapes and a lot of them are angles. We have squares, we have rectangulars, we have parallelograms and triangles that have different angles. So I'll just give a few different types of angles. An acute angle is an angle that measures as greater than 0 but less than 90 degrees. So you can think of your finger acute. If my fingers don't actually work for representation, there's also this here. It gives the angle. So as long as it is between this amount, acute means a sharp or keen. So it's greater than 0 degrees, but less than 90 degrees. So you make your finger out from either side, acute. And then right angle has a 90 degree. So if you can make an L shape with your fingers, so again, if my fingers don't match up, there's also this picture of a right angle. So it is equal to 90 degrees. Obtuse, an obtuse angle measures greater than 90 degrees, but less than 180. So you can make that with your finger. It goes greater. So again, if my fingers can't do it, I also have this picture here. Obtuse. So obtuse means blunt or with blunt tip. So it's wider than 90 degrees, but less than 180. So you know it's an obtuse angle. We have a straight angle. What is at 180? So it goes flat. So this is a 180 degree angle, as you can see in the picture. And a reflex, an angle measured greater than 180. So that would look something like this. So it's greater than 180 and less than 360. So now let me ask a question. What would a 360-degree angle look like? If you can answer in the chat box. So we have angles that are less than 90 degrees, equal 90 degrees, greater than 90 degrees, and less than 80 degrees. And then we have 80-degree angles, but what would a 360 look like? That would be a circle. So that's the next topic, is circles. So as you can see that we have here a circle represented on to the right. So I have a line going straight down from the top to the bottom, with a D to represent the diameter. It is a segment that passes through the center of the circle. So the diameter is 2 times R. So I have R being here represented by the blue line. And R is the radius. The radius is a segment with one endpoint on the center and with the other endpoint on the circle. So that is the radius from the center to the outer end there. And that can be found by, if you know the diameter, divided by 2. So those two are then the circumference, if you're using diameter, is pi times the diameter. Or if you use the radius, is going to be 2 pi r. So if you look at the picture that I have off to the right, it has the radius. It is half the distance of the diameter if you were to move it like a clock. So that's why it is 2 pi r. So twice the radius as we see with the diameter. And we get back into triangles. So we have several different types of triangles. We have equilateral. Equilateral triangles have all sides being the same. Isosceles. It has 2 or more sides the same length. Scalene. All the sides are different lengths. And then we have right triangles, which is one angle is a right angle, which measures at 90 degrees. An obtuse triangle in which one angle is greater than 90 degrees, but less than 180. And then an acute triangle is that all 3 angles are acute. So, as I was saying, an equilateral has all 3 sides being equal. As you can see in the picture, it's represented with the 2 lines showing on the sides that they are equal. Okay, now isosceles, it has 2 equal sides. So as you can see, the 2 black lines with the 2 lines on it are equal, and then the goldish looking line is greater than the other 2 lines. Scalene has no equal sides, so all of the sides are at different angles. An acute triangle has angles less than 90 degrees, so you can see that there. We have an obtuse triangle, which has one angle greater than 90 degrees. So again, with the fingers, so if your fingers can go wider than 90 degrees. And a right angle, which has one angle being 90 degrees. So we also have parallelograms with the triangles. So there are certain properties in they are shown here that congruent triangles, two triangles are congruent if their vertices can be matched. So the corresponding angles and the sides are congruent. So the properties that we have are side, 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 or SSS. Those are the shown in the top left corner of my picture box. They have three pairs of the congruent sides. They're all there. And then we have side angle side, which two pairs of congruent sides and one pair of congruent angles between the sides right there, you can see. And then we have angle side angle, two pairs of congruent angles and one pair of congruent sides. And then we have side angle side, two pairs of congruent angles and one pair of congruent sides. The sides are not between the pair of angles there. So the properties of parallelograms is that one, a diagonal of a parallelogram determines two congruent triangles. The opposite angles of a parallelogram are congruent. The opposite sides of a parallelogram are congruent. So the opposite angles and the opposite sides are to be congruent. The consecutive angles of a parallelogram are supplementary, and diagonals of a parallelogram bisect each other. So those are the four properties of parallelograms. So now that we have known the properties, we have a parallelogram here. So we have the measure of A equal to 120 degrees. So I would like to have the measures of the other angles of the parallelogram of A, B, C, D to be found. So I'll give you a few moments to try to solve the measure of the angles. So we have A, well, the measure of angle A equal to 120. So I just went over the properties of them and also of the parallelogram properties. So what would the angle of C be? That is the top right corner of it. The angle B, which is just above A, and then the angle of D. So you can answer in the chat box, and I'll give you a few moments to answer. Okay. So to find the measure of angle C, you would use property 2. So this angle of A would be congruent to angle C. So they would have the same angle there. So that'd be 120 degrees. And the property of 4 would help you find the angle of B here. And property 2 again, since B is 60 degrees, angle D would have the same measure, being congruent to one another. And that is what I have for the geometry segment of my presentation and workshop. So does anybody have any questions?
All right, no questions? All righty, awesome. Thank you so much, Ernest, for all of your hard work and for all the presentations that you've hosted so far with Finals Countdown. I really appreciate everything that you have done so far. And thank you, students, again, for participating within our event here hosted by the Learning Center. We appreciate your attendance, your participation, and things like that. And hopefully all of the information that we've put out there are useful for you, get you prepared for finals and things like that. So, hopefully some of your anxiety or, anything like that, that's, things that you're struggling with and trying to figure out from now till finals will, hopefully we kind of ease that a little bit, just as a review of all the information that we're giving you guys. So just like to thank everyone again. And we have one more session, which begins at 3 o'clock with me. And then that's basically it for Finals Countdown. And then if students weren't here the beginning, I said, as an update, we probably won't do the drawing until next week on Monday or Tuesday, because we want to allow students to complete those evaluations that we're sending out. So I think you'll be receiving some follow-up emails for sessions that you've missed or sessions that you've attended but haven't turned in your evaluations, just so you're counted towards the participation points for those gift card giveaways. So we'll send out reminder emails about that. And then I believe Monday or Tuesday, we'll be doing the official drawing. We'll probably record a video and share that to everyone that has participated within Finals Countdown. So again, thank you guys so much. Audrey has posted the evaluation for this session, which is up now. And then if anyone doesn't have any questions, we can go ahead and end at that. And we'll see everyone back here at 3 o'clock. Iga.